everyone, welcome back to the channel where we break down maths topics the easy way. Today we're talking about set notation, a powerful way to describe groups of numbers or objects in maths. Let's break it down step by step to learn about the key properties of set notation. To start off with, let's ask ourselves, what is a set? A set is just a collection of things, which we call elements. These elements can be numbers, letters, points, shapes, anything you could think of really. We write sets using curly brackets. For example, the set of factors of 6 would be represented like this. You start with a curly bracket and write down the elements that fulfill it. So the factors of 6 are 1, 2, 3 and 6. And then to close the set we do another curly bracket. These are really important when representing a set. And so on the screen we've got the set of factors of 6. Now let's discuss rule-based sets. Sometimes we don't list all of the elements. Instead we use a rule. We write it using a colon or a vertical bar as shown on the screen. On the screen I've used a colon, but where I've put a colon you could also put a vertical bar instead, like I've marked on in red. Both will be acceptable, but don't do both at the same time. This is read as the set of x such that, and then we write the rule. So x would be the set of x, the bar or the colon would be such that, and then wherever it's in condition, that would be where we write the rule. For example, the set x is a positive integer such that x squared is less than 30 would be considered as following. We have to consider what numbers fall into a set such that when they are squared, they are less than 30. The numbers in this set would contain 1, 2, 3, 4 and 5. Because if you square any of these, they are less than 30. For example, 5 squared is equal to 25. However, 6 would not be in the set because 6 squared is 36. And 36 is greater than 30, which means it does not satisfy the condition we were given. You could also write it, like I said before, using a vertical bar instead of a colon. Additionally, you could write it a bit simpler by simply saying x. So we need an x such that x squared is less than 30. This is a shorthand way of writing the exact same statement. Another property of sets is representing them using coordinates. For example, the set open bracket x comma y such that y equals mx plus c, close bracket, would represent all the points that lie on the line y equals mx plus c. You can represent any equation in the space where I've written y equals mx plus c by specifying what you want. For example, y equals x squared would also be valid. Next, the universal set and set symbols. The universal set is a set of all elements we are interested in. We often use this fancy E symbol to represent it, but you can also use a U, an S, or even an epsilon, depending on what is convenient to you. But most commonly, you'll see this E symbol representing the universal set. And I'll use this going forward. For example, if we had the universal set equals 1, 2, 3 and 6, like we had before, this shows that we are considering the set of all elements which contain the factors of 6. Now a key point to note is that if we're using a capital letter, such as A or B, These represent the set, whereas lowercase letters such as A or B, as written on the screen like this, contain the elements of the set rather than the set itself. This is just a key point that we need to be aware of going forward. Additionally, if an element belongs to the set, we use this fancy little symbol here. For example, taking the universal set above, which contained the factors of 6, we could say 3 is an element of the set by writing 3 is an element of 1, 2, 3, 6. These are all key symbols you need to know when working with set notation, and they're very good to keep in mind at all times. Finally, let's discuss set operations. There are 3 main operations you need to know about, and once you grasp them well, you can combine them to make more operations. The first one we will do is the intersection of 2 sets. We write the intersection as follows. We start with the sets we are interested in, and we write a little N-type shape to signify the intersection. This means that the elements are in both sets A and B. For example, if the set A was containing the elements 1, 2, 3, 4, and 5, and the set B contained the elements -1, 1, 4, 7, and 8, then the intersection of both sets, so A and B, would contain the elements 1 and 4, as these are the only 2 elements that are in both. The next operation is the union, which we write using the letter U, like this. If we take a look at our previous sets A and B, then the union, which means the elements that are in A or B or both, would simply be all of the elements in A, so 1, 2, 3, 4, and 5, and all of the elements in B. So -1, 1, which we've already got, 4, which we've already got, 7, and 8. The union means the union of both sets. An easy way to distinguish intersection and union is the union symbol will have a U-type shape. Finally, the last key operation you need to know is the complement of a set, which we write using a little dash. Like so. So we'll have a complement. For example, if the universal set contained the numbers 1, 2, 3, 4, and 5, and the set A contained the elements 1 and 3, then A complement would be the numbers that are not contained in A but are in the universal set. In this case, 2, 4, and 5. And these are the 3 main operations you need to know about when considering set notation. And that's it. That's a quick run through on the basics of set notation. If this helped you feel more confident about set notation, hit a like, subscribe for more walkthroughs, and drop a comment below if there's a topic you'd like for me to cover next. You've got this. See you in the next video.